Welcome back everyone. Today I'm going to show you something extremely powerful. How to build a full end-to-end data engineering pipeline in just few minutes using Python, Pandas, SQL, DuckDB, PySpark and Gradio. By the end of this session, you will be go from raw mesh data to distributed big data processing to a mini deployed app. This is exactly what real data engineers do. Agenda for the TINE data engineering. The sessions cover Python, Pandas, DuckDB, SQL, PySpark, and Gradio deployment in an interactive learning environment. Why data engineering is essential today. The data serves as the backbone of modern machine learning, AI, and businesses intelligence. Connecting raw data to actionable insight. The power of a Python in data engineering. The Python is the easy and flexibility make it essentials for data engineers. Seamlessly integrated tools like Pandas, PySpark, and DuckDB. Mastering Pandas for the data preparations. Learn to efficiently ingest and clean a data, managing missing values, and create a derived features for analysis demo. For these demonstrations, I'm going to use the Google Colab, and you can see in sections 1 with a panda. So first of all, we need to import the pandas and their aliasing as a PD. Then we have a one data set where we have a customer sales and regions, and we have a customer data where some none is there, sales none and region none. Then we are creating the data frame with help of a pandas and data, and then data frame got created. Let's try to run it. Now the this raw data got converted into that in a data frame, but still we have a non-value in it. So how to clean that in a, so cleaning that in a, and then future engineering, we have a df customer, and then fill nl will be where none is there, it will be fill that in a unknown. Same thing for sales and region, and then we are adding the additional column as a cell text with a multiply by 0.80 and then printing it. So here the transformations happen, and now you can see instead of a none we are seeing that in a unknown. So this is a this that is all about the power of that in a pandas. Now, why to choose a DuckDB for the data analysis? The DuckDB is the in-memory OLAP engines that provide that in a significant speed advantage over the pandas for analytics and BI tasks. Key SQL operations for data engineering, that is not a only, we have a many, but mastering group by order by filter aggregations is essential for efficient data analysis and filtering in the DuckDB. Let's do that in a demo. So same data frame we are going to use, where we have a data set like in customer sales region cell text and their values, and with help of a DuckDB in sections 2 you can see we are installing the DuckDB, import DuckDB, and in DuckDB object we are running the in a query, select region, then count a star as a total customer and average sales as average sales from df is above one object, group by region, and order by average sales and then again we are printing that in a data frame. So altogether you can see the set of results, whatever is there, it's printing with help of a DuckDB. Now we got that in a with help of a DuckDB SQL, and we are filtering the data from the data frame. What next? When the pandas is not enough, right? So scaling with a Spark, right? Because as the data size exceeded RAM size limits, in memory data only in computer PC or any servers, whatever's RAM capacity is there, only will be able to run it. Now, as the data size exceeds from the RAM limit, so distributed computations becomes essential. Spark provides the scalability needed for the large data sets, right? So, understanding the PySpark data frames and Windows functions. Spark data frames enable efficient big data processing, and Windows functions enhance the analysis for the ranking and inside the extractions. Let's do the demo for that as well. So here you can see we have a PySpark in sections 3. For PySpark, you can see again we are installing the PySpark, then PySpark sessions, average column row number from functions and Windows functions, and we are creating a Spark sessions with help of a name, followed by that creating a data frame, and again this df is referring from top, whatever's data we have, and now a Spark df we are creating and show. So still you can see the data is printing that in a same, but only difference is that now with help of a Spark engine, so if your data set is a million trillion or more than 5 GB of the data, then this PySpark will be process the data in that in a very fast manner. Of course, I'm running in that in this free lab environment provided by the Google, for which is research purpose, and you can see here now the data is displaying in that in a with help of a PySpark. We can see that in aggregations functions, and we can run that in a Windows functions as well. So with help of aggregations and Windows functions, we'll be able to see the results, and it is a very easy to use that in a PySpark for data engineering. Choosing Gradio for the deployment. The Gradio enables instant web app creations, perfect for the demos and POC, automatically generating a UI and shareable links. So these tools only help for data engineering for doing the POC and demonstrations. Reason why? Because as a data engineer, sometimes GUI is not completed. Let's say if you are developing the agent or any kind of a reporting, still you have a capability of the generating that in a GUI, and then you can share with your team and management for testing purpose. So this Gradio is going to help it out. Comprehensive data pipeline architectures overview. So before that, let's do the demo for the Gradio as well. So here you can see we have a Gradio deployment, and again for Gradio we need to install pip install Gradio Q, and then Gradio alias, and here we have predict text, cell text, and then it is returning the whatever amount will be entered, it is giving that in 18% of that. But Gradio have that in a iFace interface, predict text, input, output, title, and descriptions, and then launching that in a Gradio. So if I run that in this utility, you will be able to see a interface is displaying on that in a like in and that will be shareable, that we can use that in in that in a, by the browser, and we can share to that in a, some others as well. So here we'll get that, and now this Gradio is up and running, you can see, and this URL we got it. If I'll copy it and paste that in a URL, that it will be shareable, and if your PC is an internet or with help of a Gradio, they will be able to access it. Now if I'll enter that in 100 as a amount, so 18% of 100, it will be give you the sale tax as a 18 rupees, right? So you can see here how quickly and easily we are able to map with our code with a Gradio. Apart from that, in additionals, you can see here with help of our same data, we can do that in a predictions as well. So we have these predictions for getting that in average sales by the region, best regions, whatever sales we are doing, and it is predicting that in a code in that in help of a Python as well. Followed by that, now you can see we have some AI model, and now you can see the best region, we can select that the best region is coming as a west, where the sale is there the highest one. Then we have a check customer, so for best region the customer is the Peter. If I'll say, then it will be say that in a hey, that is a good sales. If I'll say that in, let's say, Ravi and sell get sales, then it is a average sales. So it is giving the kind of a predictions with help of a UI. Still we can do that in a AI model as well, right? So this is the capability of that in a Gradio. Comprehensive data pipeline architecture overview with help of a Pandas, Python Pandas, DuckDB, and PySpark along with a Gradio. Whether you are an individual learners or a corporate team, EduArn offers industry-ready data engineering training. Visit eduarn.com or comment details to get more information. Thanks for watching.